expand 1 plus y to the power of 6 in ascending powers of y as far as the term in y squared. So that equals 1 plus y to the power of 6 equals 6, choose 0, times 1 to the 6 plus 6, choose 1, times 1 to the 5 times y to the 1 plus 6, choose 2, times 1 to the 4 times y squared plus 6, choose 3, times 1 to the 3 times y to the cubed, y cubed. We are not going to continue this expansion because we only need to expand as far as the term in y squared, which you already have at this point here. So we are only concerned with the first three terms there. 6, choose 0. It's going to be 1 times 1, so the first term is just going to be 1. 6, choose 1 is 6. 6 times y, so 6y. And then 6, choose 2 is 15. 15 times y squared, 15y squared. So these are the first three terms of that expansion. In expansion of 1 plus px minus 2x squared, all to the power of 6, the coefficient of x squared is 48. Find the value of the positive constant p. Okay, so we're looking for the coefficient of x squared. So we are going to expand this as far as we need to and not necessarily the full expansion of this binomial. So 1 plus px minus 2x squared to the power of 6 will be 6, choose 0, times 1 to the 6 plus 6, choose 1, 1 to the 5 times px minus 2x squared, that's to the power of 1, plus 6, choose 2, times 1 to the 4 times px minus 2x squared, all squared, plus 6, choose 3, 1 to the 3 times px minus 2x squared to the power of 3. Now we need the coefficient of x squared. We will get an x squared out of the second term. We can clearly see we've got an x squared and that's to the power of 1. And then the third term, when we expand this bracket over here, we are going to get an x squared term out of that. We'll get more than that, but we will get an x squared term out of that. As we proceed further with the expansion, we are going to, we've got px minus 2x squared to the power of 3. We're not going to get an x squared term out of that, and we're not going to get an x squared term out of any of the terms that follow this. So we are only concerned with the second term and third term of this expansion. So we've got 6, choose 1 times px minus 2x squared and 6, choose 2 px minus 2x squared all squared. Now first we're going to simplify this. 6, choose 1 will be 6, and that's times px minus 2x squared, which is 6px minus 12x squared. And then we have 6, choose 2, which is going to be 15 times px minus 2x squared all squared. So that will give us, multiplying this bracket out, p squared x squared minus 4px cubed plus 4x to the 4. Now all we're interested in, if we just expand this, we're going to have plus 15p squared x squared minus 60px cubed plus 60x to the 4th. The only thing we're interested in are the terms that contain x squared. So we're only interested in this term over here and that term over there because they're the only terms that contain an x squared term. So the coefficient of x squared, we have minus 12x squared plus 15p squared x squared. So the coefficient of x squared is minus 12 plus 15p squared, and this, we are told, equals 48. So 15p squared minus 12 equals 48. 15p squared equals 60. P squared equals 4. And therefore P equals 2. P equals plus or minus 2, but they're asking us for the value of the positive constant P. Right? So we invalidate P equals minus 2. So P equals 2. The function g is defined by g of x equals x squared minus 6x plus 7 for x is greater than 4. By first computing the square, find an expression for the inverse of g and state the domain of the inverse of g. Okay, so g of x equals x squared minus 6x plus 7 equals x squared minus 6x plus minus 3 all squared plus 7 minus 3 all squared. The first two terms form a perfect square trinomial, so that's going to be x minus 3 all squared plus 7 minus 9 will be minus 2, and this is now g of x in turning point form. Now we're going to find an expression for the inverse function of g. So the inverse function, we're going to switch x and y around, so x equals y minus 3 all squared minus 2. And now we're just solving for y. So y minus 3 will be plus or minus the square root of x plus 2, y equals 3 plus or minus the square root of x plus 2. And this is the function, the inverse function of g. Now before we find the domain of the inverse of g, we need to consider the domain for the function g. Because our domain is restricted, x is greater than 4, we need to determine the range of g first. So if x equals 4, then g of 4 will be 4 squared minus 6 times 4 plus 7, 16 minus 24 plus 7, minus 8 plus 7 is minus 1. So when x is 4, y will be minus 1. Now since x has to be greater than 4, that means that y has to be greater than negative 1. Now the domain of the inverse of g is the range of g. So the domain of g to the minus 1 of x will be x is greater than negative 1. Question 3. The equation of a curve is given by y equals x cubed plus x squared minus 8x plus 7. The curve has no stationary points in the interval x is less than b greater than a. Find the least possible value of a and the greatest possible value of b. Now before we get into the semantics of what the question is asking, we are going to determine the stationary points if stationary points do exist. And we do that by finding an expression for dy dx and then equating that to 0, because we have stationary points for a curve where the derivative function equals 0. So dy dx equals 3x squared plus 2x minus 8, and we equate that to 0 for stationary points. Now before we attempt to factorize, probably a good idea just to find the discriminant to see if indeed we do have a solution, right? So delta will be 2 squared minus 4 times 3 times minus 8, and we're going to get a positive out of this, right? Which means that delta will be greater than 0. In other words, we have real roots. So we can continue using the quadratic formula, but it will be easier to factorize 3xx 4 and 2 plus 2 minus 4. So x will be 4 over 3, or x equals minus 2. Now x equals 4/3 and x equals minus 2 represent the x coordinates of the stationary points of this curve. Now we don't need to find the coordinates of the stationary points. All we need to do is find the second derivative and determine what the nature is of these turning points. So the second derivative will be 6x plus 2, and then the second derivative where x equals 4/3 will be 6 times 4/3 plus 2, which is clearly greater than 0, and we will therefore have a minimum stationary point where x equals 4/3, and therefore this will be the maximum stationary point. Again, we can just substitute minus 2 into the second derivative. We have minus 12 plus 2 is minus 10, so we will have a maximum stationary point because the second derivative at x equals minus 2 will be less than 0. So we've got a maximum at minus 2 and a minimum at 4/3. So in the interval, x is less than b, greater than a, then the maximum, the least possible value of a will be minus 2, and the largest possible value of b will be 4/3. So at minus 2, we're going to have that stationary point up here. And at 4/3, we have stationary point. So we can clearly see in the interval between minus 2 and 4/3, we don't have any stationary points in that interval between minus 2 and 4/3. Question 4. The diagram shows a semicircle ACB with center O and radius R. Arc OC is part of a circle with center A. Express angle CAO, which we'll just call theta, in terms of pi. Okay, so we have the center O. AO and OB are radii. If we look at sector ACO, okay, the center is obviously A, which means that AO is a radius and therefore AC is also a radius of that sector. We have a semicircle here. AB is clearly a diameter, which means that angle ACB is 90 degrees. Angle subtended by diameter at the circumference of a circle is 90 degrees. Okay, so to find the size of theta, we've got side AC, looking at triangle ABC, we've got a side AC which is R, and we've got a side AB, which is the hypotenuse of the triangle, which is 2R. So AC over AB is adjacent over hypotenuse, which is cos. AC is R, AB is 2R, and that equals cos theta. So cos theta equals a half, and therefore theta, working in radians, in degrees, shift cos a half will be 60 degrees, but in radians that will be pi by 3. Next, we're required to find the area of the shaded region in terms of r, pi, and root 3. Okay, so the area of the shaded region, we're first going to find the area of right-angled triangle ABC. We're then going to find the area of the sector ACO, from which we're going to subtract that area from the area of triangle ABC. So the area of triangle ABC will be a half base times height. The base is AC, which is R, and the height is BC. So we first have to find BC in terms of R. So using Pythagoras' theorem, AB squared equals AC squared plus BC squared. AB is 2R, so 2R squared equals AC, which is R, so it equals AC squared R squared plus BC squared. BC squared equals 4R squared minus R squared, which is 3R squared. BC is therefore root 3 times R. So the area of triangle ABC is a half R times root 3R, and that equals root 3 over 2R squared. The area of the sector AOC is a half r squared times the sector angle, which is pi by 3. So that'll be pi by 6 r squared. The area of the shaded region is the area of the triangle, root 3 over 2 r squared, minus the area of the sector, pi by 6 r squared. You can just clean that up by taking out a common r squared times root 3 over 2 minus pi by 6, and we can leave it in that form. Question 5. The dimensions of a cuboid are x centimeters, 2x centimeters, and 4x centimeters. Show that the surface area and the volume are connected by the relation S equals 7v to the 2/3. Okay, so the surface area, the total surface area is twice the length times the breadth plus twice the length times the height plus twice the breadth times the height. So it's 2 times the length is 4x, the breadth is 2x, plus 2 times the length, which is 4x times the height, which is x, plus twice the breadth, which is 2x times the height, which is x. So that will give us 16x squared plus 8x squared plus 4x squared, which equals 28x squared. That's the total surface area, which we're just calling S. The volume of this rectangular prism is length times breadth times height. So it's going to be 4x times 2x times x, which is 8x cubed. Now if we find an expression for 7v to the 2/3, that'll give us 7 times 8x cubed to the 2/3. That's 7 times 8 is 2 cubed. So that'll give us 7 times 2 cubed to the 2/3 is going to be 2 squared, which is going to be 4. And x cubed to the 2/3 will be x squared, and that equals 28x squared, which is your total surface area. When the volume of the cuboid is 1000 cubic centimeters, the surface area is increasing at 2 square centimeters per second. Find the rate of increase of the volume at this instant. Okay, so our relation is S equals 7v to the 2/3. We are required to find the rate of increase of the volume. Now, rate of increase, rate implies per unit time, and the increase of the volume is changing. We're looking for the quantity dV dt. We need to relate that to the expression we have, surface area in terms of volume. So from this, we're going to find an expression ds dV, and we need to relate this to dV dt. The volume of the cuboid is 1000 cubic centimeters. The surface area is increasing at 2 square centimeters per second. So we are given that the surface area is changing, whereas we have a quantity ds, at a rate of 2 square centimeters per second. So ds dt will be 2. We now need to relate these three differentials, dV dt, ds dV, and ds dt, together. So ds dV equals ds dt times dt dV. All we are doing is we are relating these three differentials to each other. You can start off with any differential you want, but you need to formulate an equation such that the left-hand side equals the right-hand side. On the left, we have ds dV. On the right, because we have the differential ds dt, ds needs to appear in the numerator. So we have ds dt, and now these dt's, we need to eliminate them such that we only have ds dV on either side of the equation. These dt's will essentially cancel. So this is the expression that we are going to be working with. So we need to find an expression for ds dV. So that will be 7 times 2/3 is 14/3 v. 2/3 minus 1. So we v to the minus a third, and that equals ds dt, which is 2 times dt dv. Don't get too concerned about dt dv. We are looking for dv dt. We're just going to end up inverting whatever fraction we get. So the first thing we're going to do is just divide both sides by 2 so that we get this expression dt dv on its own. Dt dv will be 14 over 6 v to the minus a third, and then we are now just going to invert this such that we get dv dt, and that will be 6 over 14 v to the minus a third, which is 6 v to the third over 14. Now when the surface area is increasing at 2 square centimeters per second, the volume of the cuboid is 1,000 cubic centimeters. So we're going to evaluate this when V is 1,000 cubic centimeters. So it'd be 6 times 1,000 is 10 to the 3 to the third divided by 14. So that will be 60 over 14, which is 30 over 7 cubic centimeters per second. A line has equation y equals 3kx minus 2k, and a curve has equation y equals x squared minus kx plus 2, where k is a constant. Find the set of values of k for which the line and the curve meet at two distinct points. Okay, so we've got two functions here, and the fact that they meet at two distinct points means that we have 2 points of intersection, right? So when we equate these two functions and establish a simplified expression and find the discriminant for that expression, the discriminant must be greater than 0, because delta, the discriminant being greater than 0, implies we have 2 points of intersection, two real roots. So x squared minus kx minus 3kx plus 2 plus 2k equals 0. X squared minus 4kx plus 2 plus 2k equals 0. Delta equals b squared minus 4ac. That's minus 4k all squared minus 4 times 1 times 2 plus 2k. That equals 16k squared minus 8 minus 8k. And this expression for real roots, delta must be greater than 0. So 16k squared minus 8k minus 8 is greater than 0. We can divide through by 8. So 2k squared minus k minus 1 is greater than 0. 2k and k, 1 and 1, plus 1 minus 1. So the critical values, k is minus a half, k equals 1. Graphically, we could do this algebraically. Graphically might be easier, quicker. These critical values represent the x-intercepts of this corresponding quadratic function. So the x-intercepts are minus a half and 1. Then we're going to have a function shaping up because the coefficient of k squared is positive, and we are looking for values of x where y is greater than 0, where we have positive y values, and that will be to the left of minus a half and to the right of 1. So k is less than minus a half, or k is greater than 1. For each of two particular values of k, the line is a tangent to the curve. Show that these two tangents meet on the x-axis. Okay, so for the line to be a tangent to the curve, when we equate these two functions, the resulting expression must have the discriminant equal to 0. So we're not going to go and do this all over again. The discriminant we had was 16k squared minus 8k minus 8. Now delta must equal 0 for equal roots. So 16k squared minus 8k minus 8 must equal 0. So that's 2k squared minus k minus 1 equals 0. Recall that k equals minus a half or k equals 1. That'll be the solution to this quadratic equation because those are the critical values for the previous question, which are the x-intercepts of this particular quadratic function. So when k is minus a half or k equals 1, then this line will be a tangent to the curve. So when k is minus a half, the straight line will be 3 times minus a half x minus 2 times minus a half, which will be minus 3 over 2x plus 1. When k equals 1, then the tangent will be y equals 3 times 1 times x minus 2 times 1. That would be 3x minus 2. Minus a half will be y equals x squared minus a half x plus 2, which is x squared plus a half x plus 2. In the quadratic, when k equals 1, then y equals x squared minus x plus 2. Now we need to show that these two tangents will meet on the x-axis. So this is the one tangent, and that will be the other tangent. So we need to equate these two. So 9x equals 6 and x equals 2/3. Now if we substitute 2/3 into either of these equations, we should get y equal to 0 because that will imply that the two tangents meet on the x-axis where y values are 0. So y equals 3 times 2/3 minus 2. 6 over 3 is 2. 2 minus 2 equals 0. So that checks out. We can test it with the other line as well, just to be sure. Minus 3 over 2 times 2/3 plus 1. That'll give us minus 1 plus 1, which is 0 again. So the two tangents meet on the x-axis. Question 7. Show that the equation 3 cos to the 4 theta plus 4 sine squared theta minus 3 equals 0 can be expressed as 3x squared minus 4x plus 1 equals 0, where x equals cos squared theta. Okay, we have two trig ratios here, cos and sine, and we need to obviously express it as a single trig ratio. So we are going to express sine squared theta as 1 minus cos squared theta, which we get from square identity, sine squared theta plus cos squared theta equals 1. So 3 cos to the 4 theta plus 4 minus 4 cos squared theta minus 3 equals 0. 3 cos to the 4 theta minus 4 cos squared theta plus 1 equals 0. Now, if we let x be cos squared theta, that means that cos to the 4 theta will be x squared. So we can express 3 cos to the 4 theta minus 4 cos squared theta plus 1 as 3x squared minus 4x plus 1, and that equals 0. Then solve the equation 3 cos to the 4 theta plus 4 sine squared theta minus 3 equals 0. So the expression that we had, just remember that we called x cos squared theta. We could therefore express this as 3x squared minus 4x plus 1 equals 0, which is going to factorize as 3x minus 1 times x minus 1. X equals a third, or x equals 1. We called x cos squared theta, so cos squared theta equals a third, or cos squared theta equals 1. Cos theta equals plus or minus 1 over root 3, or cos theta equals plus or minus 1. Now the domain for which this equation is valid is theta is between 0 and 180 degrees. So just looking at finding the reference angle for the first equation, theta equals 54.7 degrees. That's the reference angle for cos theta equals 1 over root 3. Now, we're looking in these two quadrants here, in quadrant 1 and quadrant 2, because that was the domain given to us. So 54.7 degrees is in the first quadrant, that's the one solution, and the second solution is 180 minus 54.7. So theta equals 54.7 or 125.3 degrees. So that's the solution to the first trigonometric equation. Cos theta is plus or minus 1, so the reference angle will be 0 degrees or 180 degrees. So this is the solution for this trigonometric equation. So theta is 54.7 or 125.3 or 0 or 180 degrees. The function f is defined for x is greater than a half and is such that f prime x equals 3 times 2x minus 1 to the half minus 6. We're required to find the set of values of x which f is decreasing. Now a function is decreasing when the first derivative is less than 0. So we've got the first derivative f prime x, which is 3 times 2x minus 1 to the half minus 6. And we need to find the set of values of x for which the function f is decreasing. So 3 times 2x minus 1 to the half minus 6 must be less than 0 in order for the function f to be decreasing. So 2x minus 1 to the half is less than 2. We square both sides now. We'll have 2x minus 1 is less than 4. 2x is less than 5. X is less than 5 over 2. And we were told that the function is defined for x is greater than a half. So we're going to take that into consideration as well. So x will be greater than a half and less than 5 over 2. And that's the range of x values for which the function f is decreasing. It's now given that f of 1 equals minus 3, required to find f of x. So we are given the derivative function and we are required to find the curve itself, f. So we need to integrate this expression in order to get f of x. So f of x will be, 3 is a constant, so it'll be 3 times 2x minus 1, a half plus 1 will be 3 over 2, and then we divide by 3 over 2. We also divide by the derivative of 2x minus 1, so divide by 2. And then we're integrating minus 6, so it'll be minus 6x, and then we add the constant of integration plus c. So f of x will be 3 divided by 3 over 2. It's the same as 3 times 2/3, which will equal 2. And then we divide by 2, so it'll just be 1. So we'll have 2x minus 1 to the 3 over 2 minus 6x plus c. And this is our curve. And we are told that f of 1 equals minus 3. In other words, when x is 1, y is minus 3. So minus 3 equals 2 times 1 minus 1 is 1. 1 to the 3 over 2 is just going to be 1. So we'll have 1 minus 6 times 1 is 6 plus c. So therefore c equals 2. So the function f of x equals 2x minus 1 to the 3 over 2 minus 6x plus 2. The first, second, and third terms of a geometric progression are 3k, 5k minus 6, and 6k minus 4 respectively. Show that k satisfies the equation 7k squared minus 48k plus 36 equals 0. Okay, so these are the first three terms of a GS. That means there's a common ratio between successive terms. So 5k minus 6 over 3k equals 6k minus 4 over 5k minus 6. Therefore, 5k minus 6 all squared equals 3k times 6k minus 4. 25k squared minus 60k plus 36 equals 18k squared minus 12k, and therefore 7k squared minus 48k plus 36 equals 0. We're now required to find the exact values of the common ratio corresponding to each of the possible values of k. So in other words, we're going to need to solve for k from this expression. So it factorizes 7k minus 6 times k minus 6. K equals 6 over 7, or k equals 6. So the terms will be 3 times 6 over 7, 5 times 6 over 7 minus 6, and 6 times 6 over 7 minus 4. So that's 18 over 7 minus 12 over 7, 8 over 7. Common ratio between successive terms will be minus 2/3. And the second sequence will be 3 times, the first three terms at least, 3 times 6, 5 times 6 minus 6, 6 times 6 minus 4, so 18, 24, 32, and the common ratio is 4/3. One of these ratios gives a progression which is convergent. Find the sum to infinity. Now, for a series to be convergent, the common ratio needs to be between -1 and 1, greater than -1 and less than 1. That's the condition for a series to be convergent. Now, the ratios we just established were -2/3 and 4/3. -2/3 is greater than -1 and less than 1, and 4/3 is greater than 1. So clearly this is r equals 4/3 is not applicable. Therefore, we can determine the sum to infinity, which is a over 1 minus r when r equals -2/3. The first term for the sequence where r equals -2/3 was 18 over 7 divided by 1 minus -2/3, so 1 plus 2/3. 18 over 7 divided by 5 over 3, and that equals 54 over 35, which is approximately 1.54. The diagram shows part of the curve y equals x minus 1 to the minus 2 plus 2, and the lines x equals 1 and x equals 3. Point A on the curve has coordinates 2, 3, and the normal to the curve at A crosses the line x equals 1 at B. We're required to show that the normal AB has equation y equals a half x plus 2. Okay, so to determine the equation of a normal, which is a straight line, we are going to need to know the gradient of the normal and a point that lies on the normal. Now the point is evident because we are required to find the normal to the curve at A, so we've got the point A. So that we've already got. We just need to find the gradient of the normal. To find the gradient of the normal to the curve at A, we're first going to need to find the gradient of the tangent to the curve at A. To do that, we're going to differentiate the function y equals x minus 1 to the minus 2 plus 2. So dy dx equals minus 2 times x minus 1 to the minus 3. We then multiply by the derivative of x minus 1, which is just 1. and the derivative of a constant is 0. So dy dx is minus 2 times x minus 1 to the minus 3. Now, at the point A, where x equals 2, we can find the value of the gradient of the tangent to the curve at A. So dy dx, where x equals 2, equals minus 2 times 2 minus 1 to the minus 3. That's minus 2 times 1, so the gradient is minus 2. And this is the gradient of the tangent to the curve at A. So therefore, the gradient of the normal to the curve at A would be the reciprocal of 2 with opposite signs. So the gradient of the normal will be a half. So we have the gradient of the normal, we have a point that lies on the normal, point A. So we can now determine the equation of the normal. So y minus y1 equals m times x minus x1. You can also use y equals mx plus c if you prefer. So y minus 3 equals a half times x minus 2. Y equals a half x minus 1 plus 3. So y equals a half x plus 2. And this is the equation of the normal to the curve at A. To find the volume of revolution obtained when the shaded region is rotated 360 degrees about the x-axis. Now the first thing to notice about this is that we don't have a smooth curve. We have a straight line, which is the normal AB, and then we have the curve y equals x minus 1 to the minus 2 plus 2. Now the problem here is that at this point we have a discontinuity. That means we cannot simply integrate between x equals 1 and x equals 3 because we have two different curves. We have a straight line, then we have a curve. So what we are going to do is we're going to split this shaded region into two regions. At this point here, I drop a perpendicular from the point A to the x-axis. We're going to have region 1 and region 2. Region 1 will be integrating the normal, the straight line, between x equals 1 and x equals 2. So the two curves in question really are the normal, the straight line, and the x-axis, which has equation y equals 0. That'll give us region 1. In region 2, we can integrate between x equals 2 to x equals 3. The curve y equals x minus 1 to the minus 2 plus 2. And again, the curves in question will be the curve itself and the x-axis. So essentially, the reason we are doing this is because we have this discontinuity. We cannot simply just integrate between x equals 1 and x equals 3 because we've got two different curves here. So the volume of a shaded region will be the volume obtained in region 1 plus the volume obtained from region 2. So we've rotated the shaded region about the x-axis. We have two regions to work with. The first region, we are going to integrate between the lines x equals 1 and x equals 2. We can integrate the line y equals a half x plus 2. We'll create a cross-sectional cut, the radius of which will be r1, and that will be the difference in y values between the curve y equals half x plus 2 and the x-axis. So radius 1 will simply be half x plus 2. And then for the second region, we have a cross-sectional cut, the radius of which is r2. That will be the difference in y values between the curve y equals x minus 1 to the minus 2 plus 2 and the x-axis y equals 0. So radius 2 will be x minus 1 to the minus 2 plus 2. Now the volume of revolution of the solid will be the integral from x equals 1 to x equals 2. This is now first region. The area of each cross-sectional cut is pi r1 all squared, and we integrate with respect to x. Pi r squared is the area of each cross-sectional cut, and dx represents the thickness or the height of each of those cross-sectional cuts. So area times height will give us volume. The volume of the first region plus, we can integrate between x equals 2 to x equals 3 pi r2 squared with respect to x. So pi r2 squared, this will be the area of each cross-sectional cut of the second region times dx, the height of each cut, will give us the volume of that second region. So the sum of those two integrals will give us the volume obtained by rotating the solid about the x-axis between the lines x equals 1 and x equals 3. So the volume of region 1 will be pi times the integral from x equals 1 to x equals 2 r1 squared, so it will be a half x plus 2 all squared dx. We're going to need to multiply this bracket out. So pi times the integral from x equals 1 to x equals 2, that will be a quarter x squared plus 2x plus 4, and the integral will be the integral of a quarter x squared will be x to the 3 over 12. The integral of 2x will be x squared, and the integral of 4 will be 4x. That's evaluated between x equals 1 and x equals 2. So the volume of the first region will be 91 pi by 12. The volume of the second region will be pi times the integral from x equals 2 to x equals 3 of r2 squared, so that will be x minus 1 to the minus 2 plus 2 all squared. Again, we need to multiply this bracket out. That equals pi times the integral of x minus 1 to the minus 4, x minus 1 to the minus 3, and divide by minus 3. Also divide by the derivative of x minus 1, which is just 1, plus 4 times x minus 1 to the minus 1, and then divide by minus 1. So we're just going to change this sign here to a minus. And then the integral of 4 will be 4x, and that's evaluated between x equals 2 and x equals 3. So the volume of the second region rotated will be 151 pi over 24. So the volume of the solid obtained when rotating about the x-axis will be 91 pi over 12 plus 151 pi over 24, which equals 111 pi over 8 units cubed.